Season 3. Work done. Physics in Necrotic World. Episode 52. Equilibrium. Welcome, strangers. Temperature decreasing means energy emission and stable energy absorption. Temperature increasing to more than its surroundings, so beyond room temperature. Well, depends what's in the room, really. I mean, what if you have a frozen mammoth or pickled gherkins in the process of freeze drying? I mean, I don't think we ever dry gherkins. I think that defeats the point of pickling them. It's practically a pickled cucumber. It's like a salted saline cucumber. It's like a cucumber who's been to the hospital and just been on a sailing trip. But it's a cucumber. I don't know where I'm going with that. Okay, wait. Anyways, more than surroundings means that it radiates more energy than it absorbs. Thermal equilibrium means temperatures are constant and stable, and actually there's not much left to say. Energy absorption rate is balanced, so equal to energy emission rate. More energy can be stored by the atmosphere with more greenhouse gases, for the better or worse. Taking a stab, to the future of the world as we know it. I mean, the world has geographically changed a lot. We've had multiple supercontinents. I mean, over them billions and billions. I mean, not billions. Well, billions. Through 13.8 billion years. Or is it million years? I need to know that. How about you search that up? Yeah, I'll search that up after. It might be in the space topic as well. I mean, the world has geographically, changed a lot since we've had multiple supercontinents like Pangaea and Gondwana. It's very cool. Really, really cool. There are some awesome documentaries online. I mean, would totally recommend. Total energy in is equal to, so balanced, the same as total energy out. You can't get nothing. I mean, you can't get something for nothing. You can't get nothing for something. That doesn't make sense. You can get nothing. You know what? You can't get something for nothing. Explaining things is where you're meant to pull out the memory banks and think. Yeah. You put the effort in and the effort comes out, apparently. I mean, obviously you also have the thermal energy that's just radiating and being wasted. Maybe that's where, like, revision disappears sometimes. Yeah. That makes sense, right? See you next time at Physics in Necrotic World. This is your host, Rimona Christian, out. Physics in Necrotic World, Season 3, Work Done, Episode 53, Global Impact. Welcome, strangers. Okay, so, with YouTube, I don't know why it's just not loading, because the other episode 52, is 2 minutes long, right? I mean, not 2 minutes, like 2-3 minutes long, yeah? So, what I'm going to need to do is combine this episode with the other episode. But they're technically still 2 separate episodes. But just consider it 2 separate episodes. But I'm going to have to join it together. But I have to do this episode. Okay, you know what? I'll just start quickly. When the atmosphere is being mega bike pump inflated, like, with more infrared radiation derived energy absorption rates, this means that global temperatures increase, which goes on until energy absorption rate and energy emission rate is balanced. This is called, you guessed it right, thermal equilibrium. A lot of that in energy topic, somewhat surprisingly, not that much, not that surprising. Heat transfer can be slowed down but not stopped by insulation. High temperatures mean higher emission frequencies and increased intensities. White is a popular summer color for clothes, bags, even especially for houses. Very fashionate. White. It's totally in season. In summer, anyways. High temperatures mean higher emission frequencies and increased intensities. In hot countries, white houses are like a prominent feature, yeah? Somewhere down, nicely snug around the equator, yeah? Somewhere about there. Surfaces that are painted white are rubbish absorbers of infrared radiation and have mediocre emitting skills. which means that it keeps the house cool within the house, yeah? Well, relatively cool anyways. I'd hope it still looks cool, but it's all really a matter of semantics, really. Solar panels, yep, even the one in the calculator that's in your blazer pocket. I mean, sometimes when you can't be bothered to find your pencil case and you put it in your blazer pocket, the calculator, I mean, I like my calculator. That's really random. Okay, let me continue. They heat quickly, solar panels, because they have black surfaces which are brilliant absorbers of infrared radiation, so quickly charge up your house's electricity, or in your direct case, your pi function button, and they're good emitters, so your calculator does not fry your hand from the sun's rays and constant exposure of you doing calculations lovingly with it. Actually, I mean, pi is not really a function, it's a mathematical constant, which is irrational and derived from the relationship between the circle's circumference and diameter in a really cozy, snug ratio. In Excel spreadsheets, there is a pi function, which is like a binary shifted gamma function, which can calculate factorials, but obviously that's different from the pi that you use in GCSE maths, for example. Intensity and wavelengths vary based on color, surface area, and sheen. Perfect black objects like, well, Vanta Black. I mean, Vanta Black was a nice, notable attempt of a nice paint that's really black, like a black color, really, really dark. But it's not really that perfect of a black body, like it's not a perfect black body, because they're meant to have reciprocal radiation, absorb and radiate to thermal equilibrium. It's ideally meant to absorb all frequencies of light. Is a black hole, or actually a white hole, a perfect black body? Well, actually, that's a nonsense question. I think I'm just going to end up saying a lot of actuallys this season. A black hole is close to a perfect black body, but no black body in existence yet, perhaps because the universe is not that old. Black dwarfs do not exist yet, following the same universe is too young theory. Stars are considered close approximations to a black body. A black dwarf is a great absorber but a rubbish emitter. Gravity does not allow for light to escape in black holes, but they emit Hawking radiation. So a perfection in the universe, in terms of a perfect black body, is theoretical, non-existent right now. See you next time at Physics in Necrotic World. This is your host, Rimona, R out.